Hi, so this is my setup. I believe these are called pack powers or something like that. PS power DC 500. This is like the Light Akita Engineer 500 one. This particular model does the test, charge, and discharge. So these are just finished testing, putting together 2 new batteries coming up. But as they discharge on the discharge cycle, it'll tell you how many milliamps each cell has. It also tells you the resistance of each cell, the time completed. This particular model also serves as a power bank. So putting in these 4 cells with the electricity taken off, you see out 5 volts DC. There you'd hook up your phone charger, and this turns into a portable power bank as well. So you can charge, test, discharge the cells. These particular cells, I removed them from a 9-watt battery that I got on, actually a few of them that I got on eBay. The BMSs were burnt out. They weren't regulating the cells evenly anymore. But these cells are rated at 2,600, and as you can see, most of them, just what you can see here, 2,700. But most of them that I come up getting out of the pack will come out to 2,700. So these just came off with a second charger, and I always write the milliamps and the internal resistance. I also mark, when I take apart the actual batteries, I write down their end voltage on the bottom of the cell, so I know which ones were the ones that were low on voltage and why, more or less. So as you can see here, it has number 6, number 4, number 5. Those are the actual battery packs where it came in. It had 20 cells to each pack. So this way I can single out where the problem is, to see if it's a problem of the batteries failing, as it was in the pack, or it was just from very rigid use. The 9-watt is kind of like a hoverboard. So usually the BMSs, when they start to fail, they won't manage the cell anymore because they balance each cell. So as it's starting to drain, as you're riding and you're giving it a as you're discharging each battery, they're supposed to discharge evenly. But if you don't have a battery management system, or BMS focus, if you don't have a BMS or a battery management system, each cell would discharge on its own, and that's where you start having problems. So a lot of times in your power tools, they'll usually fail because of the actual BMS chip, the battery management system chip that's in there, that regulates each and every cell. So this is how I single out my batteries, and then I put together, if you go on it's some website there, Cell Packer or something, and like that you input each capacity for each battery in there. I love you. Each capacity for each cell, and it actually puts together the recommended cells in each series pack. So I'm gonna have a 14S, so 14 cells in series, and then 6 in parallel. So that's how we're going to be putting this together. As you can see, the resistance values are fairly close, which tells you it's a good battery. If it was a bad battery, you'd be looking at like 150 resistance, which means that the dendrites, which are inside the cell, as you charge and discharge in them, depending on how violent you charge all the way and then discharge as low as you can get it, that starts building these dendrites, and once they connect inside of the cell, they'll short it out. Or if they're really close already, you'll have a really high resistance, which will mean that that cell is bad and you shouldn't be using it in a battery pack where you're gonna have, like 84 different batteries. So I'm putting together a 14S battery, and 14S, so it's 14 batteries in series and 6 in parallel, so 6 times 14, and you'll have 84. That's what I'm putting together. There for these dirt bikes, I like to go around the block with the kids, and I'm about 160 pounds.
And this is my dirt bike, and I'm only 6 years old.
So these batteries I put together myself. This one's about a 7.5 amp hour, 58.8, so 60 volts more or less. This one is his, so I got something a little smaller. This one's 54 volts, 48 volts nominal, but it's a 48 volt, 10 amp hour battery, and that one serves him good. He can ride for a good hour and a half, 2 hours, giving it max throttle. But these things are 36 volts. They're rated for 36 volts. So this one's got a 60 volts pretty much, and that one's got 55 volts. And they run great. This one hits around 28 miles per hour with my 11-year-old on it. And with me, I can get 25 miles per hour.
With me, it goes super fast.
Yeah, it goes super fast.
Blasting. I go faster than that with you on it.
So this one used to be his. This one's a 24 volt, which I modified that battery as well. That one's a 10 amp hour, 24 volts that I put together from Cobalt, 24 volt battery, that Lowe's brand. Over here, these are called battery testers. You'll find chargers that just charge the cells, but they don't discharge, so you don't get this milliamp rating and the resistance and all that stuff. So these are pretty detailed. This is one that I'm gonna put together. So when you take apart the battery, they usually have these little stuff. So these little from where they spot weld it, they'll have a few pieces of metal connected to it. But just so we have a flat surface, I go ahead and I grind those down, so I get a good contact surface. So when I spot weld, it'll be nice and clean and you don't have any variations. So here, you just pop in each cell. It does have voltage protection just in case you put it in the wrong way. It doesn't usually happen to me, but it does have that protection there just in case. So here, you'd hold the mode button, press it twice, you go to test. This one you can only, this is for the charge current at 1,000 milliamps, or 1 amp per hour. And here I'm going back and forth through the cells. So here's the second cell, cell 3, just gotta press it and hold it. Double click, put the current on 1,000. Same thing for the last one. So test 1,000, just go through it just to make sure. And these are 2,600 milliamp hours, so they'll be there for a long time. Well, this one says 5 hours charge time, so it was probably another 4 or 5 hours to discharge the battery. Because first, when you put it in, First it charges it, then it discharges, and then charges it up again. And it does all of that just with that test one, so you don't have to be going back and forth between those. And then I just write down each cell value, and then just to make sure I got the resistance thing right, I'll pull it back, I reconnect it. See, it'll say a different value. So that's fully charged up. And I'll proceed to do that. Take each and every one. Take them all out and I put them in there. These were the cheapest ones that I can find. This is probably like a knockoff of the light Akita, and they're here in the US. All the other battery testers, see it says test charger on it, DC 5000. The light Akita one is light Akita or Likita or something like that. Engineer 5000 or 500. So here you can see. Focus. Alright. So depending on how many cells you have, it can charge faster or slower. So if you put 4 cells, it'll charge it at a max of 1000. At 3 at a max of 1500. And if you only got 2 cells running, it'll charge them both at 2 amps each. So it'll charge a lot faster. So if each one of these cells is 2600 amps, if you put it at 2 amp or 2000 milliamp, which is the same as 2 amp, it'll charge each one of these cells in a little over 2 hours. A little over an hour, actually. I went ahead and I attached these fans, these computer fans on them. I just tied it into the same thing, just to keep these things down, because as they start the whole charge and discharge cycle, this unit itself actually gets pretty hot, which feeds the hot air into this over here. And with these little fans, I mean, all the way from where I'm standing over here, I can feel it. So it's a good thing for the batteries, just so I don't put them to charge too high. And I'll be right back. I'm gonna show you the batteries that I just recently put together. So this is the most recent battery I put together. I'm still waiting for the BMS to come in. You can see I spot welded all of these on, so each cell has 2 points of contact, so we can get the max amperage out of each series connection. Got a XT90 on there. We should be getting around max of around 36 amps. That's what this rated for. But I have 6 in parallel, and 6 has a total of 10 amps. So this battery can handle 60 amps max. So it's better if you have your battery set up for a higher capacity than what your controller is going to be putting, so nothing heats up. So this battery shouldn't be heating up at all, especially in any of these contacts. I got an 8 gauge wire on there, so nice and thick. This is rated for up to 60 volts, 60 amps. I've used a 10 gauge, which is a little thinner, and it didn't get hot, but you know, why not? And this is what I'm going to be using to charge them up. I have a step up, step down buck converter, which I'm going to be using. These are server power supplies, and they are rated. We're going to be going with the 110 to 120 volts, which is what the house electricity comes with. So we're going to be pushing 12 volts, 75 amps on each one of these things. So these are 12 volts. So I'm going to be doing a series connection between these over here. So negative to positive on one side, and then the two that are left over will be together on one of these pins. So I'll have 24 volts, slash 75 amps capable coming out of this charger right here. If you were to go online and buy the equivalent, a charger like this would probably cost you around $300. So this right here is do-it-yourself. You gotta short some of these pins out over here just to get it to turn on when you hook up your power cable. If not, it won't turn on. And then this is the positive terminal. This is the negative terminal. So here you can connect anything you want that's 12 volt capable. So here I have another connection for my hobby charger that I used to use, and just in case I need to use it to charge anything. But this will be powering this is the step-up converter. So it brings in the electric house supply. So it's going to be coming in through the 120 over here. This converts AC to DC. This has a 30 volt max in. So the higher the volts you put in coming here, the easier it'll be on. This converts 24 volts to charge up to 80 volt battery. So we're going to 58.8 volts. Here you can dial down how many volts go in and out. So this one unfortunately came defective, so I'm getting another one today so I can put everything together. But house electricity, AC comes in through here. This converts to AC to DC. DC out through here at 75 amps max. I'm only going to be charging these batteries. I think I'm only going to be using like 5 amps per hour. Having 6 parallels, we're looking at around, I think it's like 15.5 amp hours for this battery. So at 5 volts, it'll take about 3 hours to charge. I'm going to be playing with that to see how much I can push into it. Just want to charge it as fast as possible, but as safe as possible at the same side. I can probably push 10 amps into this battery and charge it really quickly, but I haven't tried it and I don't want to risk it. So after I take out those batteries out of the charger, I can start putting them in here. I actually have them in order from when I first started. So the first pack on the bottom was the first one. And then I started going back this way. And then I start from the top this way, so I can actually keep track of which pack this one came out of. Just to keep things organized. And that way you can single out which cell you want to use to put your pack together. I'm gonna need again around 8. I'm gonna need 84 batteries, 84 cells to make one of these. This has 84 batteries in total. I was gonna use this for my electric bike, but it's kind of square. So this one I'm giving to my oldest son in one of those dirt bikes we saw earlier. And the one that he has, we're gonna keep it as a secondary battery. Just in case when we go on long trips or we go bike riding and stuff, they can last. With the battery that I had is currently in the dirt bike, we recently did 16 miles, so 8 miles over and 8 miles back. We weren't going full throttle the whole time. We were kind of going slow because we had the little blue dirt bike, which goes a lot slower. So they weren't going full throttle the whole time. So the batteries lasted, the 48 volt, the blue battery, and the other battery lasted the whole time. But I want to put this into my oldest son's bike, and then I'm going to be making this same battery, but in a triangle formation. So I did it yesterday. I went ahead and I put all the cells together on this cardboard, and then I fit it into the inside triangle where my bicycle has. And it actually fits in the entire hole, and at the bottom I had enough space for the controller, so everything is gonna fit inside the triangle, and I'm actually gonna organize. So how you see these batteries over here, or these cells, you can do the same thing in different shapes. So this one can be square, this one can be like a triangle, the other one could be like a T. As long as they all have the same contacts and you wire them correctly. So every time you parallel two batteries, each one of these banks, this whole positive one, when you connect them all together like this, their top voltage is 4.2. So it's pretty much adding 4.2 and 4.2 on each time you parallel a cell. So every time you have one of these parallels, you're going to be having 8.4, 8.4, 8.4, 8.4 until you get the negative and the positive, the total voltage that you have. So in this case, 58.8. I'll take another video once I got this one all put together. I'm still waiting for the freaking BMSs to come in. Damn coronavirus. It's holding everything up.
Yes.
Holding us from having fun. But at least we got the other ones we can ride around with. So yeah, that's the project. I'll keep you all updated.
And wait a second. He is the best battery maker.